Welcome to everyone. Today I am going to compare fundamental of SDN technology, and that fundamental I am going to compare between ACI and DNAC. I think all of you are aware that SDN technology having three subparts. One for data center, one for wide area network, and one for our campus network. So DC network belongs to ACI, this belongs to SD-WAN, and this particular belongs to DNAC. So that comparison we are going to compare today. I will explain what are the things we have in the ACI and what are the things we have in the DNAC, where things are very rigid, where things are up to us. That we are going to understand. So let's start the fundamental. So in this section, first we are going to understand in ACI. In ACI, we need to remember that we have fixed and rigid design. That is called spine, and leaf architecture. In this, what we have, suppose we have two spine switch and we have leaf switches. We have leaf 101, leaf 102 and leaf 103. Suppose this is my spine 201, spine 202, leaf 101, leaf 102, leaf 103. How we are going to connect them? Each and every leaf connected with every spine. So this spine 201 connected with all the leaf, spine 202 also connected with all the leaf switches. We can't change this design. And here we have the one option in the spine. We have the option to use Nexus 9500, and this leaf part we are using Nexus 9300. We have some Nexus 9300 switches which can also act as a spine. So thing is here, which protocol works here? The protocol works here to identify the layer 3 connectivity. For layer 3 connectivity, we have protocol intermediate system to intermediate system. We can't change this protocol. This is the fix. This runs automatically. And then this is for layer 3. For layer 2, we have the protocol that is called VXLAN. And then my server form remain connected with this leaf switches. When my server form remains connected with leaf switches, now which protocol identify them? How spine come to know which devices are connected with my leaf switches? That protocol is called Council of Oracle protocol. This is actually control plane protocol of spine. So here we don't have any option to change the part. Neither we can change the design, devices are fixed, and this protocol are fixed. Now on the other end, in the DNAC, we have the option that you can say we have two switch. This is my underlay switch. This switch can be anyone. Any layer 3 device can act as underlay. And now we have the fabric edge switches. Here we have fabric edge. Actually, these are the edge switches from where our end points are going to connect. And now how they can recognize with each other? We have the one device that is called my control plane device. Now, these underlay switches connected here and underlay switches for the redundancy purpose is connected here. Now, then you can say what the difference we have is spine and leaf, the DNAC and ACI. Yes, difference is that in the DNAC, we have the option to use underlay switch. Otherwise, we have the another option so that directly edge devices can connect with the control plane. We can omit this particular underlay switch. Here we have this flexibility. We don't have this flexibility in our ACI. Another thing, to have the layer 3 reachability in our DNAC, You can say that part is our SDA, software defined access. Any protocol, like here we have the option to use OSPF. Here we have the option, by default ISIS will work. We can't change this part. Here we have the option to run OSPF. For layer 2, it is fixed, that is VXLAN. Now, how endpoint recognized by control device, control plane device? That is my control device. You can say how they can recognize. Here we have location ID separation protocol. So if you will compare in the ACI network, which is the control plane protocol of spine, that is COOP protocol. In our SDA part, what is the control plane protocol for our this controller part? That is called LIPS. And I think you are aware with this particular part. So endpoint, here we have in the LIPS protocol, we have endpoint identifier, and then we have the router locator. This part is here. In ACI, this is the fixed design. Here we have the flexibility. Another thing is that now here we have connected our EPIC controller. So in ACI network, controller is EPIC. In our SDA network, controller is DNAC. So when we are doing the manual configuration in our DNAC part, we have the option to choose any layer 3 protocol. It's on up to us. And then this LIPS protocol identify the endpoint. When we are going to do the fabric discovery under DNAC part, then automatically here we have the similarities. Like in ACI, fixed protocol is ISIS. When we want to discover fabric, here again, last protocol will come. That is again ISIS protocol. In that part, we can't change that particular configuration. This part remains the same. ACI used for the data center. This DNAC SDA used for our campus network. Here we are recognizing endpoint. In the DC part, we are recognizing our servers. This difference we need to remember. It is not to recognize the endpoint. Like in DNAC, we have multiple endpoints here. This endpoint is going to recognize by this particular controller. That is called fabric discovery. Here we have the fabric discovery. This part is called my fabric discovery, and these protocols automatically comes here. And then in the fabric discovery part, we have the option. First we'll do the manual configuration. We have the choice. After that, once we are doing the LAN automation part, automatically ISIS protocol will come. In this part, we are doing some basic configuration. Now, which devices we can use here? These devices are SDA enabled device. Any device we can't use here. Like here, we have the fixed partner, Spine 9500 Nexus. Here we have the Leaf 9300 Nexus. Here we have the option, any catalyst. We can use 8000 series, we have the 9000 series, we have 45, 65. But remember, the devices which we are going to connect with the endpoint, that device must be SDA enabled. So this point we can say we have the similarities. Certain devices are fixed. Underlay part, we have the option we can use any device. For this control part, here we have the option so that it can also understand the SDA fabric network. So this part we need to remember. So this is the thing. What the things we have in ACI for data center, DNAC for campus network. ACI recognize our servers here, which server we are using for our data center functionality. In the DNAC, we are recognizing endpoint. Certain protocols are fixed here. We have the flexibility. Here we have the design part. We can remove this underlay directly. This edge devices connect with the control part. That is to recognize the fabric. And then protocol, we have the flexibility. At the time of manual, we can use any protocol. Automation part, automatically ISIS will come. So COOP protocol recognizes the devices which connected with the leaf. In this part, that is called location ID separation protocol. So guys, if you want to learn more, go through our recording and subscribe our channel. Thank you.